Welcome back to the SuperDataScience podcast, everybody. Super pumped to have you back here on the show. And today we've got a super special guest joining us, Scott Clendaniel. Scott, welcome.
Thank you so much. I'm really happy to be on.
That's awesome. I forgot to ask you, where are you located right now?
I'm actually in Havre Grace, Maryland, off the Chesapeake Bay, about 45 minutes north of Washington, D.C.
Havre Grace, Maryland. Is
Absolutely.
the name of
Chesapeake
the city
Bay.
is Havre Grace is the name of the city.
Yes. Port of
Okay.
Mercy, I believe, is the loose translation.
Very interesting. How did you end up there? Have you been there for a long time?
Actually, we just moved here. We had an opportunity because of my job allows me to work remote to be able to change location. And my wife is a children's librarian and just got a position up here near Cecil County.
Mhm.
So yeah, we just moved here and we're pleased as punch. It's really pretty.
All right. And tell us, and before that, where were you located before that?
I was actually born in Baltimore, Maryland, lived there for a long period of time, and then I was in Delaware, Pennsylvania, and a few years in Honolulu, Hawaii.
Amazing. I've always wanted to go to Hawaii. Like, what is Honolulu like?
Honolulu is really a fantastic city. I really loved living there. Obviously, a lot of tourism, but the people there were just so warm and inviting.
Uh-huh.
Really had a good time there. Big fan of Hawaii.
Okay. But and Honolulu, what island is Honolulu on?
Oahu, which is the main island. About three-quarters of the population lives on that island. There's a total of eight.
Wow. Wow. I heard there's a great restaurant on Maui and it's called Mama's Fish House, I think. Do you know of that
Now, I
one?
don't know that one. I haven't been there, but I visited four of the eight islands while I lived there.
Uh-huh.
Maui's very pretty. Each island sort of has its own personality, which is fun.
Like what's the differences in personality?
Well, like Kauai is the garden island. So
Mhm.
it tends to be much more laid back. It is probably the greenest of the islands.
Uh-huh.
So that's great. The big island has all kinds of different topography. It's probably the only place in the world where you can go snow skiing and water skiing on the same day.
Yeah,
So
wow.
each island has its own unique factors to it. Maui's a lot of fun too. Oahu is where most people go. That's where Waikiki is,
Yeah.
and that's probably the most popular of the group.
Oh, fantastic. Really cool. So the mountains are tall enough for skiing.
Only on the Big Island, and when I say snow skiing, I'm not talking about Aspen or Vail, Colorado. I mean, you can get not that much snow, but at least you can move. You can at least tell people, hey, this is fantastic. On the same day, I went water skiing and snow skiing.
Amazing. Okay, gotcha. Well, Scott, it's a pleasure to have you here. We've got a lot to go through. So for those who are listening and maybe don't know, I posted on LinkedIn just, hey, Scott Clendaniel is coming to the show in 24 hours, and a post your specifically asked for advanced data science questions. In that 24 hours, there's now 56 messages in there. And thank you very much for taking the time to really answer to some people. There's been a lot of cool discussions, and I want
Absolutely.
I really want to go through
And
as many
very
as we
few
can.
of them were from my bill collectors, which I really appreciated. So yeah.
Gotcha. Okay. So what I want to start with, though, so we'll definitely get to those, and there's some really cool advanced machine learning questions, model, and cross validation and things like that. Before we get there, give us a bit about background around yourself. Like, who is Scott Clendaniel?
Sure. Actually, I have a bit of an unusual background. My undergraduate, my MBA are both in strategic planning. They're not in either statistics or computer science, which makes it relatively different from a lot of other folks in the field. I was in financial services for a long period of time and all the way up through vice president of consumer lending at Bank of Hawaii. And unfortunately, I had a family emergency where my ex wife at the time decided to take my son. And so I had to leave. And she had indicated to my son, who was only 3 years old at the time, that I had actually gone because I was packing his toys in Hawaii. So I was like, why did you do that? Anyhow, so I got a phone call from my 3-year-old son one day. He says, Daddy, are you done packing my toys yet? Oh, that was like the worst thing ever. And I was like, gosh, I've got to figure out how to give up my career in financial services and do something else. So I thought to myself, I wonder if anyone's interested in this machine learning, artificial intelligence stuff. I wonder if I could do that. And so for the next 16 years, I became a consultant. So to all those folks out there who are trying to break into data science, if I can get past that, you can get past whatever you're facing currently. And I encourage everybody to give it a shot.
Wow, wow, what a story. So you just packed your stuff, gave up a vice president position at Bank of Hawaii, and moved back to mainland US. How did that go for you?
That was rough. I'm not going to deny. But it opened up a world of opportunity, and it also gave me a whole new perspective on what's important in life and what isn't, and also gave me a lot of focus on persevering and
Yep.
problem solving and how I could add value to others. And so it was a tough thing to go through, but it provided a lot of opportunities for me later on in life.
Wow, wow, amazing. And could you tell us, please? So 16 years passed, you were consulting in the space. What happened next, and where are you now?
Absolutely. Morgan Stanley actually recruited me to be their first full time data scientist in their Baltimore office.
Hmm.
So that was great. And unfortunately, they had a situation with some internal fraud where, and I can share this because it was on the front page of the New York Times, someone walked out the front door with $11 million. So they suddenly changed my role to focus exclusively on internal fraud, which wasn't really what I wanted to be doing at that point in time. I wanted to stick with machine learning. So I was recruited away from Lake Mason and have been there for 2.5 years. And we just got purchased by Franklin Templeton. So I've been trying to help build functions for those organizations.
And just to give a bit of background on Franklin Templeton, this is one of the world's largest global investment firms, right?
Yeah, once the transaction is completed, which will probably be about the time this podcast is released, it'll be approximately $1.4 trillion in assets, making us the sixth largest in the world.
Wow, that is crazy. And as a lead data scientist at this company, what is your role? Like, do you actually look at how to invest this money, or are you looking for fraud, or is it like a broad scope of applications? What exactly do you do?
Yeah, most asset management firms have separate groups who do the actual portfolios of investments. So I'm not involved in that so much. I help working on other types of business problems like optimizing sales, trying to help in profiling customers and opportunities, occasionally some small pieces of fraud detection, and actually trying to educate the organization as a whole on best practices and analytics and trying to make sure that we can sort of meet the academic component of what's going out in the world versus the real world, and trying to bring people up to speed, do a lot of training for folks,
Hmm.
laying out, helping them form their own business plans and helping them build their models.
Hmm.
So it's
Hmm.
kind of far
Okay.
reaching.
Okay, gotcha. So quite a broad scope of applications, but not specifically the investment management. Okay, interesting. Very interesting. Hope you're enjoying the podcast, and we'll get straight back to it after this quick announcement. And this announcement is going to be a bit tough for me because it is about my own book, so please excuse the shameless plug. However, I do believe in it so much that I want to get the word out there. This book is designed in a way to get anybody and everybody up to speed with data science, pretty much everything that is important, that is needed to get going. And the unique proposition of this book is that it doesn't require coding. There's a lot of books out there on data science where you need to sit in front of the computer and code in Python or R. This book, you simply take and you can read it on your lap, in a car, on a plane, in your backyard, on a couch. You can read it anywhere. There is no coding in the book. It focuses on intuition. So if you've taken our courses and you like those intuition tutorials about how an algorithm works and why, rather than what the code behind it is, then you're going to love this book, and it's going to be a great way to solidify that knowledge. It covers pretty much everything in a data science project lifecycle, from asking the right questions to data preparation to machine learning to visualization, and finally presentation. So pretty much everything you need in your career is covered. So if that sounds exciting, check it out. It's called Confident Data Skills, available on Amazon. It's the data science book with the purple cover. And please enjoy. Okay, well, on that note, I think let's dive into these questions because there's quite a lot to go through,
Let's
and I think
go.
that'll take us. All right, awesome. So I've gone through the questions. This was on LinkedIn, and I've sorted them in order of, we're going to start with the most advanced machine learning, AI, deep learning stuff first,
Oh,
and
fine. No
then
pressure on me. That'll be great. Okay, go ahead.
here we go. Okay, so Vignesh, if I'm pronouncing that correctly, Vignesh asks, can you give us a brief about about the real world applications of data science in the investment industry? How do you approach a particular problem in this space?
Sure. I think one of the big components in any field is actually trying to make sure what is the business problem and defining that first before you actually define your modeling approach. In investment management, there are a bunch of different problems where data science can be applied, and also financial services have been involved in advanced analytics since at least the 1960s. So it's a great field to be in. But a couple of examples would be fraud detection. How do you tell whether a particular transaction is someone spoofing, whether they're the real person or not? There's developing portfolios and which assets should be in there. You can look at time series forecasting of how an individual investment is going to perform. You can also look at things like one of the problems I've been working on a lot recently is sales optimization. So, how does a financial advisor look at the broad palette of customers and potential customers and figure out who should be prioritized in terms of what their needs are and coming up with a product recommendation on what would fit their needs?
Okay, okay, gotcha. So yeah, it ties in well with what we just spoke about, that there is a broad scope of applications in business problem. Gotcha. What specific AI technologies have so this is Matthew. Matthew asks, what specific AI technologies have changed the investment industry? Yeah, and which do you predict will shape the industry in the next 5 years?
Sure. I think the development of additional algorithms to be available to us has changed AI quite a bit. Deep learning, perhaps not as much as others, but things like XGBoost and algorithms that allow for ensembling have really helped the industry quite a lot. Also, approaches in terms of anomaly detection for fraud detection, they've been huge contributors as well. So
Uh-huh.
those are probably the changes in AI that have impacted the most. Also, the growth of open source have made it very difficult for organizations to say no. There was a time many, many decades ago where people would say, "Oh no, I'm sorry, we can't do anything without a software package that costs $90,000," and now they can't say that anymore. So I think that's actually had probably the biggest impact on the growth of AI overall.
Uh-huh. Gotcha. Gotcha. And next 5 years?
Next 5 years, I think there are going to be huge opportunities in terms of predicting credit performance and also fraud detection. Those are extremely difficult problems to solve, and having the more advanced AI technologies, I think, are going to continue to help in that arena, especially fraud detection, because it keeps changing. So, what appears to be fraud in one given quarter may look very different the next quarter because the fraudsters are always adapting and changing their approaches. So, you need to have a technology that allows the models to continue to grow over time. You can't just pick a point in time and say, okay, we know what fraud is, because it won't be the same next quarter.
Gotcha. Before I forget, I wanted to say that Scott is sharing his comments today on behalf of himself and not on behalf of the organization that he works at. So that's these are just opinions at the end of the day.
So, it's all my
Our
fault.
opinions.
I want to make that really clear. Everything I say is my fault, no one else's.
Thank you, Scott. And well, speaking of fraud, do you know what the size of this problem globally or in the US is per annum?
I don't have recent statistics on that, but it runs into the several billions of dollars.
Mm,
And the challenge is the fact that you not only lose the profit on the given transaction that would come in if it turns out to be fraudulent, but you lose the entire dollar amount. So in financial
yeah.
services, your inventory is actually the dollars that you manage. So if you
Uh-huh.
have a fraudulent transaction, you lose every bit of that inventory along with any type of profit you would have made.
Okay.
So it runs into many, many billions of dollars.
Yeah.
So it is a huge issue. It's also
Yeah.
really complicated because the fraud rate, the percentage of transactions that are fraudulent, tends to be very low, but its
Yeah.
financial impact is ridiculously large. So it's a
Yeah.
real class imbalance problem.
Yeah. Yeah. I just did a quick search. The global fraud market size for fraud detection and prevention market size is valued at $17.3 billion. So, as you said,
And
massive,
that's
massive
just the
risk.
market to stop the fraud. That's not the fraud itself. So, yeah, you get
Yeah.
a real clear picture of how big an issue it is.
Yeah. That's a good point. Um, I only know one, like, so kind of like quite intuitively I know what, or like I've read about one specific fraud algorithm that I could confidently explain, and that's Benford's law.
Okay.
Are there any algorithms that you can share with us?
Sure. And actually, I'll make a recommendation of something to be careful with. There has been a huge amount of press about using anomaly detection for fraud detection. And that is very helpful. It does have some pretty severe limitations, though, in that a given fraudster is going to try very hard to not look like an anomaly. So, in other words, to some extent, the data is actually fighting against you. The fraudster is trying to look as similar as possible as it can to the mean of any given transaction. So, they're
Yeah,
actively fighting you to not look like an anomaly. So, the problem is the false positive rate on anomaly detection is enormous and it's very difficult to fight against. So just using anomaly detection, regardless of how sophisticated the version that you're using is, uh, tends to have some severe limitations that you're going to come up against. So just be aware that it should be one tool in your arsenal. It shouldn't be the be all and end all.
gotcha. Okay, anomaly detection is one. That's fantastic. So I'll share Benford's law. Benford's law is a more of a kind of aggregate tool. It doesn't look at individual transaction. It looks like as a whole. And the way we were taught it at Deloitte is that if you take a like I might be paraphrasing what they taught us back then. So again, I'm speaking from my opinion as well. You take all the transactions on all of the values, dollar values on a balance sheet of a company, just like take all of them, put them into, mix them all up, put them into a bag, and then look at the distribution of the first, is it the first? No, of the, yeah, of the first digit in all of these transactions, right? So what is the first digit in like of these, all of these amounts, right? So what's the first digit? How many number ones are there? How many number twos are there? How many number threes are there? So the leading digit. And Benford's law says that the distribution should be, they should be 30% ones, 17% twos, 12% threes, 9% fours. So it drops off as you go further. It's kind of an intuitive thing. And that is something that is really hard to fake, right? Like if you're faking a balance sheet and you're making up numbers, you don't think of that distribution in mind. So you might make your numbers look really believable, but overall, when you take the distribution on the first digit across all the numbers, it's not gonna follow Benford's law, and that's how a qualified expert can tell that, hey, there's something going on here.
In forensic accounting, that becomes really important. And that is definitely one of the warning signs. There are a couple interesting things about Benford's law, in addition to what you said, and I think you gave a great explanation of it. Benford's law seems to apply even if you change the base unit. So if it's not a decimal system, if you used a base 8 system, you will tend to see very similar patterns. The percentage of digits will change. But I just find it amazing that even if you change the base number that you're using, that it tends to show up. And it's great for things like reviewing the balance sheet, just as you mentioned. What becomes tricky is the fact that when you're dealing with consumer transactions, for example, the actual transactions don't apply as much for the trailing digits. So, like,
Mhm.
everybody wants to charge $1.99 or
Oh
$1.95.
yeah.
They don't tend to charge $1.03. So you actually have the opposite problem there. So
Mhm.
you have to be careful. So Benford's law is extremely powerful when you're looking at a whole collection of numbers, given one instance, such as a balance sheet. It becomes
Mhm.
much harder when you're trying to look at individual transactions.
Awesome, awesome. Thank you. Well, there we go. That's two techniques in fraud detection. And speaking of fraud detection, we have a question from again Vignesh, who says, while working with fraud detection problems, most of the times we come across imbalanced data sets. Can you please put a light on how to overcome such problems or how do you resolve it? Maybe to start off with, what does it mean that the data set is imbalanced?
Sure. So this is typically referred to as class imbalance. So in other words, if I'm trying to do a classification problem, and let's say that I'm trying to do fraud versus non-fraud, if you look at the distribution of how many transactions are fraud and how many transactions are non-fraud, your fraud rate tends to be relatively small, down into the tenths or hundredths of a percent. So the problem is if you try and compare the fraud transactions versus the non-fraud transactions, a lot of algorithms are going to choke on that unless you adjust the balance of the data set so that you can have more of a 50-50 ratio between fraud and non-fraud. Because otherwise, what the model's going to do is go, let's see, I've got 1,000 transactions, 990 are not fraud, and 10 are fraud. I've got it. They're all not fraud. And it's going to be right 99.9% of the time, which is going to mess everything up. So you
It's gonna
need
have
to make it much
fantastic
more difficult.
accuracy, right?
Yeah, that's amazing. I'm done. I just said there is no fraud, and I'm going to go home and have lunch. That doesn't work out too well in the real world. So what you do is you tend to oversample what's called the minority class. So in this case, the fraud transactions. I might take most of every fraud transaction I can get that is in my training set.
Yeah.
And I'm going to compare it against an approximately equal number of non-fraud. And that means that the model can't just arbitrarily say, okay, everything's not fraud. That's the technique that I use the most. There are other techniques that you can use, including doing all sorts of complicated things with synthetic data or smoke techniques or those types of things. But the oversampling the minority class, so lots and lots of the fraud and much fewer of the non-fraud, has been the technique that's worked the best for me. It's also very simple.
What's the drawback? What's the potential danger of using this technique?
Part of the problem is you may not have enough fraud cases to use in the first
Yeah.
place. So you may have such a small number of records that you may not be able to use that um, in its purest form. But you're definitely going to want to move your sampling as close to a 50-50 ratio as you can.
Okay. Okay. Gotcha. So, but as long as you select the other ones, the non-fraud ones at random, you shouldn't have like any bias in your model because you didn't use all of the available
Correct.
non-random.
And use of random becomes really important. And some of the experts in the group who have classic statistical background can talk a lot more about random versus non-random, in that there is no true random, but there are all sorts of techniques you can use to make sure. For most of the work that I've done, I just use a random functions in Python or SQL, and
Mhm.
that has worked pretty well for me, and I haven't run up against issues.
Okay. Well, awesome. Um, Speaking of Python and SQL, what kind of tools do you use in your day to day?
Python, Spark, are the most common. I actually, because I am older than dirt, I started doing this all the way back in 1986, God forbid.
Wow.
Um, so I actually grew up using GUI tools like SPSS, which is now owned by IBM, Salford Systems, which is now owned by Minitab. Lots of other GUI tools. There's actually a free one, especially if you're just starting in the field and you don't have a developer background, called Orange Data Mining, which is included in the Anaconda distribution. Those are a couple places that you can start. But eventually it tends to turn into a lot more Python as the starting point, and probably Spark if I'm using a distributed system to build.
Gotcha. You said orange data mining.
Orange data mining. Yeah, it is not the prettiest program you will ever encounter. The interface looks at least about 20 years out of date. Don't be fooled by how the interface looks, because
Yeah.
there is a lot of power underneath it, and a lot of people get turned off. They're like, oh, this doesn't look cool. This doesn't look like something that was built for Apple. I'm not going to use it. I would say that's a mistake. They've actually done a
Yeah.
really good job of creating a sort of GUI interface to sit on top, and then underneath it primarily uses Python and C to actually
Okay.
run
And
the
is
algorithm.
this primarily for like building models or fraud detection?
Any type of model.
Yeah. Gotcha. Awesome.
Yeah, I've been
Awesome.
really happy with it. People laugh at me when I show the screenshots, but it actually works pretty well.
Gotcha. What kind of models have you noticed work the best for fraud detection? Because we've got like a huge range. You know, k-means clustering. We've got naive Bayes. We've got um, logistic regression. We've got XGBoost and so on. What would you say are your go-to models when you have fraud detection problem? What's your first, second, third choice?
Um, First of all, I'm going to throw out an old theory that I hope people look into, which is essentially called the multiplicity of good models, which means if you have the right data and you've prepared it the right way, all sorts of algorithms are likely to give you a very similar positive result. If you haven't done the data prep correctly, you will start to see wide variances. That being said, ensembling techniques of any type would be my favorite, probably the most common being XGBoost. Also, as a data prep technique, I recommend target mean encoding. That can be extremely helpful. In terms of the final technique, I always recommend ensembling because each algorithm has its own strengths and weaknesses. So if you ensemble a group of different models together, you're likely to end up with a better result. The final model is usually a logistic regression based on the inputs of the XGBoost and other types of techniques in the family.
Wow. Thank you. Very, very detailed and advanced. This data prep technique you mentioned,
I'm
target mean
sorry, I get
encode.
really passionate about this stuff, so I may bury you in detail, and I
That's
apologize in
okay.
advance.
That's okay. It's okay. I want this to be an advanced discussion. Well, advanced learning for me. I
Okay, that's fine. That's fine.
I wanted to ask this data prep technique, target mean encoding. I don't know it. I haven't heard of it before. Could you tell us a bit about it? If you can, like, just explain what does it do and how do you use it?
Sure. Let me give you a really simple example. Let's say that we are an auto insurance company and we want to predict whether the old myth that red cars always cause more problems than others. So I've got a red car, a blue car, a yellow car, a white car, and a black car. So I've got 5 different car colors. And I want to encode into my model this categorical variable. So rather than use the original values of the colors in the variable, you use a transformed variable, so a new variable. And instead of recording the car color there, you actually put the claim rate for each color. So if a blue car has a 0.1% claim rate, you put 0.1 anytime it's blue. If it's really red, you'll use 0.2% anytime red shows up. So in other words, you convert the original categorical input into its actual target mean. What's the mean rate that this issue is going to come up with? And you use the transform variable as opposed to the original variable. It tends to work better than one-hot encoding, which you would usually use. And also you can use it in pretty much any algorithm, including algorithms that only take numerical inputs like the original XGBoost.
Wow. Wow, that's awesome. I hadn't heard of that one. I've heard of one hot encoding, but still, do you mind refreshing my memory on that, please?
Sure, one-hot encoding. So for each of our 5 car colors, we're going to take the original variable and we're going to move it out of the data set, and we're going to create 5 new variables. One variable is going to be, was the car color white? 0 or 1. If it white, you give it a 1. If it wasn't white, you give it a 0. Then you have a second column that says, was the car color blue? Third variable says, was the car color red? You can run into
Gotcha.
issues with that in that you can end up with a sea of categories, and you can overload your model with way too many inputs.
Mm-hmm. Mm-hmm. Gotcha. Gotcha. And you also got to be careful of the dummy variable trap there, right? You have to have one
Absolutely.
less than the original number of categories. Okay. Gotcha. Very interesting. Thank you. That's very exciting. Okay, so let's move on. Now let's talk a bit about models. So Sonam, I hope I'm pronouncing it right, asks, what are the parameters to look out for and or tests to perform that indicate model drift while monitoring a production AI or machine learning model? To start off, what is model drift?
Sure. Model drift is kind of a silly name, but basically it means that the performance is going to drift over time. All models tend to decay over time, and different models decay at different rates. So there are a couple things that I'd suggest with this. Number one, assume that your model is going to decay over time. Don't guess it's going to decay, just assume it's going to decay and set up a schedule of when you're going to retrain any model you have. So that's the first component. Plan for obsolescence before you put the first model in. It's very important. Second thing is I use what's called a population stability report, which sounds like some sort of bizarre sociology experiment. But essentially, what it's doing is to say, my data that I started off with in one period, how similar does it look to data that I'm looking at right now? Are those two populations similar or not? When the population stability report comes up and says, hey, wait a minute, your data starts to look different, you definitely need to retrain your model, in that the world that the model is trying to represent has changed, and therefore the accuracy of its predictions has changed. So just assume it's going to happen. I get kind of irritated with folks who just want to go out there and say, I have created the world's greatest model, but it's based on data from 7 years ago, and I don't know why it's performing poorly. Come on, seriously? Put in your model, test it constantly, and use that population stability report to keep your eye open to see that the world's changed.
Gotcha. Okay, a couple of questions here. So, first one will be, why, like, this might be a naive question, but like I'm just tempted to ask, why do models decay over time? Why do they never get better? Why is it that way?
Okay, trick question. They
Mhm.
decay over time because they represent the world as they knew it, and the world changes.
Yeah.
So the model does its absolute best to represent the world as it saw it in your training set.
Yeah.
So when the world changes, the type of data that shows up in your training set may drift. For example, let's pick an easy example, inflation. Prices tend to rise over time for lots and lots of things. So if your original model was based on prices from 3 years ago, the prices now look different. So the model needs to adapt to reflect that change to come up with a representation of what happens today. So that's why all models tend to drift. However, that isn't necessarily a bad thing, in that you may have learned more information over time. You may have a larger data set to look at. You may have found new variables that you didn't see before. You may have new algorithms you want to test out. So actually, in the end, you can end up with a model that is more accurate than the last model was at its peak. So over time, you actually can get better. And that's one of the things that's exciting to me.
Once you update it, of course, right? Like if you leave it alone, it's not going to get better.
No, I wish.
uh, okay, gotcha. And in in your answer on LinkedIn, so it was really inspiring to see that you went through and answered to everybody. You do a huge part for the
Tried.
data
If I missed
science
anybody,
community.
send me a message.
Awesome. You mentioned that 6 months is your like magic number to look at. Why is that?
It is completely arbitrary. And I'll tell you why. If you try and make it annual, it tends not to happen. It is in the real world. Organizations are like, oh, no, we did it last year or whatever. If you make it 6 months, you keep it top of mind with
Uh-huh.
everybody. So 6 months is sort of the outer limit. And then if the
Yep.
population stability report says, wait a minute, the world looks different, or the performance of the model tends to fall up, you've got a fraud model and your fraud rate keeps inching up. Either of those two
Mhm.
events, you look at it in a shorter period of time. But if you actually build that into the calendar on the front end and also explain to your stakeholders, model drift is a thing. And modeling is a process. It's a process of learning and it's adapting to change as information changes. So just bake that into the schedule from the beginning and you're going to be in a lot better shape.
Hmm. Hmm. Been there. Was at an organization once where uh, they didn't look at the model. Like some consultants delivered like a segmentation model. They did. Oh no, prediction model. Prediction in terms of who will churn, who won't churn. So didn't look at it for 18 months. When we had a look at it,
Ouch.
yeah, it's accuracy dropped from like 78% or something like that down to 49. So it was better to flip a coin.
Well, and let me throw out a made up word for everyone, and that's non-stoptimization. So instead of
Nice.
optimization, if you're constantly nonstop trying to optimize, you call it non-stoptimization. And senior management loves phrases. I'm kidding. But if you take on that theory that I'm always going to be improving my model, that it's an organic process, that, it's something that you put in as a regular business process, as opposed to this snapshot one-time event that's going to fix all our problems, I think you'll be in better shape.
Okay, great. The population stability report. What do you look at there? Do you look at like means, distributions?
Yeah, it'll
Or
actually
maybe?
give you an indicator on a scale of 0 to 1 and on how much things have changed.
Oh, is it? Is like it's a library
So
in Python?
yeah. So for example, if incomes on the original data set were $62,000 and now it's $140,000, something's wrong.
Yeah.
It also helps you to figure out if your data stream has been corrupted. So in other words, let's say the model works fine when it has accurate data, but somehow something has happened and now the data isn't as good as it was before. You
Yeah.
can then go in and say, okay, wait a minute, something's wrong. The
Uh-huh.
population looks different from what it was before. Maybe we've got a problem in the database. Maybe we've got a problem in how the data was collected. Maybe we've got metric versus English units issue that suddenly popped up.
Okay. Okay, gotcha. But so anybody can go and download this population stability report, or everybody needs to build their own
Yes.
version of it?
Yeah, the formulas are out there. I can't recite it
Okay.
off the top of my head, but yeah, if you just type into Google population stability report, it can give you a walkthrough of that.
Awesome. Fantastic. Speaking of data collection, there was a question from Santosh. Um, how do we check stability and consistency in the process before using the data it generated for model building? And so I understood there was like a bit of, he meant one thing and she first answers another question and answers the second one. So let's start with the first one. The first one was like, in terms of like, how do we check for stability and consistency in terms of the data collection process?
Sure. Usually this is done sort of further upstream before when we get data. So this is usually done by the folks who are doing your data ingestion or your ETL process on the data upfront. The point he's making is extremely valuable. If it's as simple as garbage in, garbage out. If the data you're putting into your model has flaws in it, your model isn't going to work. So
Yeah.
one of the things is actually sit down with the people who are the stewards of that data. How is this collected? How often? How long have we been keeping track of this? This is also one of the reasons why data visualization is so important. See if the data makes any kind of sense before you start loading it into your model. His point, I think, was data scientists are so excited. They want to have a model. They want to have results. They want to use their area of expertise. They want to pull the algorithm out of the quiver and start shooting. And that is a problem if you haven't checked the data consistency up front. I will give you a real world example from a client who shall not be mentioned, where the original data stream, there was some type of corruption when data was migrated from one database to the next database. So if it was a dollar amount, they literally physically typed the dollar sign in the value. If
Hmm.
there was a comma, they typed the comma. If there was a decimal, they typed the decimal. At other
Uh-huh.
points in time, this wasn't true. So it was just the raw number. So you've got, this is why you really need to understand your data. And to his point, you need to make sure that data seems to make some type of sense and sit down with the steward of that data to make sure that you understand what you're dealing with before you get too far down the pike.
Awesome. Gotcha. Um, And then you also talked about in your answers something that intrigued me. You said that if for some reason like the data is corrupt, then cross validation of the model should also fail. So basically, we could probably use cross validation, as I understood, as a indication whether there's problems in the data or not.
Absolutely.
Tell us a bit more about that.
The great thing, the great thing about models and cross validation is it's virtually impossible to come up with a great cross validated model based on bad data because it
Mhm.
just won't work.
What
Because
is
when you're
cross
taking
validation?
cross validation, you're taking your original data set and you're dividing it into what they call folds. So let's say we're going to take our data set and we're going to break it into 5 folds.
Hmm.
You test the first model built on 4 of the folds and you leave out the 5th. On the
Hmm.
second one, you may use folds 2 through 5 and you test it on the first. You want to make sure that those results look very similar.
Hmm.
And if they don't, you've got a problem in the model. So you either average the results of the folds, or what I tend to do is definitely do that first part, but also go back and say, what is weird about that one fold that doesn't seem to be working very well? Why is the performance off for this version versus that
Gotcha.
version?
Gotcha. Are the folds? Is the data in the folds randomized? Like before you select the folds, you randomize it.
Absolutely.
Okay, gotcha. So just to recap, let's say we have um, uh, I don't know, 100,000 or 500,000 records. Then you break it down to 100,000, 5 groups of 100,000 each. In the first um, version, you train the model on the first 4 groups of the data, and on the fifth one, you test it. In the second version of the model, you train it on the the first, second, third, and fifth groups, and then you test it on the fourth, and then you train it on the first, second, fourth, and fifth, and you test it on the third. So you're always kind of like shifting this window, and you should up to like ideally you should be getting the same results throughout, similar results.
They should be really similar. And also, your final model should take the average of each prediction.
Hmm. Okay, gotcha.
There are some
But does
folks
it?
who just use cross validation for like testing hyperparameters and things like
Yeah,
that. I actually, if production
yeah,
allows me to be able to use all 5 models and take the average of the scores, that's what I like to do.
gotcha. If but if you have corrupt data or probable errors in the data, wouldn't like if you randomize the data before you do the 5 bands, right? Wouldn't the corrupt records, wouldn't they distribute equally across the 5 bands, and therefore the model would still perform identically, but
It
still there would be
Well, it would be identically terrible performance.
yeah,
So you're not
yeah,
just looking to see that it differs among the 5. If my area under the curve is 51%, I've got a problem.
okay,
So I need to be really aware of that. And
gotcha.
so to your point, yes, they will look similar and they will look similarly awful.
Okay. Okay, gotcha. Gotcha. Could you do the cross validation without randomizing first? Then you would more likely have like one of those bands that is definitely like underperforming.
It's sort of no. I would not recommend that because you lose the real advantage of the randomization is the fact that it eliminates or it greatly reduces the chance that you're just looking that a few records are off or that you've got outliers or that type of.
Uh-huh. Gotcha. Gotcha. Okay. Awesome. Thank you. Okay. Da-da-da-dum. Next one was there's an interesting question. So this one is more about complexity of machine learning models. So what is your experience? This is a question from Desmond. What is your experience with the complexity of machine learning models and alpha or outperformance? Do the most complex models, XGBoost neural nets, yield the highest alpha, or are there other factors that yield higher alpha? For example, type of data, feature engineering, etc. First of all, what is alpha?
Well, I'll tell you what, I am going to do what all good interviewees do. And when they don't have the pure understanding of the answer, they change the question. So I'm going to treat this as a question on overfitting as opposed to the pure definition of alpha. So I'm going to
Mhm.
regard overperformance as a function of overfitting the model. which means that it's basically memorizing the data. As I said, I am older than dirt. When I went to school and studied math, they used to do this weird thing where they would give you the answers to the odd numbered question in the back of the book, but they wouldn't tell you the answers for the even number questions. So what would happen is, if you just tried to memorize the answers, you'd only be 50% right.
Mm.
Models tend to be very greedy. If they get the chance to memorize the answers, they will do it. And so what you want to do is to make sure that it's very difficult for the model to actually do that. Otherwise, what it's learned is what the answers to the specific records that you gave it is, as opposed to identifying the true patterns that can be applied to other folks. So if I went and I got a suit and it was completely custom fit, but for somebody else, it's not going to fit me very well. It's overfitted to the wrong person. So I want to make sure that my model generalizes well. I want to make sure that my model applies to all kinds of different people. And
Okay.
so overfitting is a big problem. The more complex the model, such as deep learning, if I've got a 600 layer deep learning neural network and I've got 10,000 records, I've got a problem, because in many cases, it's going to try and memorize the data itself as opposed to learn the patterns. So algorithm can be a component. You can also have data leakage issues where it's memorizing the answer because it's actually included in the original data set. So the ways to avoid that, or an answer to the question, algorithms can be a problem. The data can be a problem. There are all kinds of things that can lead you down that path. Ways to get around that, or to use very robust validation methods, including cross-validation, to try and eliminate the possibility that the models actually memorize the answers in the back of the book.
Okay. Wow. Wow. That's fantastic. I just got like transfixed on your answer. You like caught me off guard
Oh,
with
sorry.
that. That's awesome. Okay. Thank you. Definitely an important point to look at. At what point, at what stage would you say people should keep that in mind when they're building a model?
From the beginning, part of what we as data scientists, we tend to be really tempted to jump in and build a model. I'm a
Yeah.
model builder, so I want
Mhm.
to build a model. And that might not be the first thing that you do. You really have to have a solid design in terms of what your model building process is going to be. And coming up with the validation strategy should be one of the first things you do, because you've got to segment your data out into what's going to be test, what's going to be training, what's going to be validation or cross validation before you start the modeling process, or you've already contaminated the experiment, so to speak.
Mhm.
So in your process design, before you sit down, that should definitely be a component that you look at.
Okay. Okay. Gotcha. How much time should be spent on designing that process versus implementing the model?
Well, if you come up with a standardized process in terms of how you select variables in your randomization, you can actually sort of bake it into the process. So once you do it once, you shouldn't have to repeat it a whole bunch of times,
Mhm.
but you should definitely be very robust on your first models and see what components you can redo. Like randomization should be something you should be able to do in every model in a specific
Mhm.
script. You shouldn't have to reinvent the wheel every time.
Gotcha. Okay. The follow-up question from Santosh was, he said, give an example. So let's say I want to build a forecasting model for daily pizza sales, and say I have data for the past
A
one
man
year.
after my own heart, pizza sales.
My question is, unless the processes that drive for pizza sales are consistent, we can't rely on the data. For example, there was a change in employees every month, the change in tools being used, and so on. On the other hand, if the pizza store is started just a few weeks ago, it might not have reached the state to be considered. So the main thing is, if how do we know, like, if there were changes in the process? Like, you have data for a whole year, but then there were changes in the process, employees, or like how we do sales and so on. Can we still use that for modeling?
Sure. And what I'll say to that is, you're absolutely right. Very important point, but it is very rare that a modeler is ever going to have a perfect data set to start with. So the trick is, what is my decision making process now? And can I improve it with the model? And if so, by how much? So you never get to perfect. You try and get to a perfect representation of the system for your pizza prediction. But every organization has employee turnover. Every organization has some of those elements in play. And that's why you also have to be very careful with your validation strategy to make sure that your model holds up on data it's never seen before. That's why I keep sort of banging that drum. But the question is there something that I can learn from the data that I have right now using standard validation procedures? If I can, and I increase the performance of my decisions, if I make 10% better decisions, does that help my business? And if it does, the Teddy Roosevelt quote about do what you can with what you have, where you are right now, and make sure that your client, whoever is going to be using your model, understands this is what I think I know. This is what I don't think I know. This is how much I think I can improve performance with the model over where you are right now. And then you work with the client to say, is it worth the effort? Is the juice worth the squeeze, so to speak? And that's why you need to work with your client as opposed to just turning this into some academic exercise off in an ivory tower.
Nice, fantastic. Okay, Scott, thank you. Those were all the advanced questions. We're moving on to the world of
Okay.
more. You did well. You did really well.
Okay.
we're
All
moving
right.
on. We're moving on to more soft skills and predictions and forecasts. Okay, for the future. So, a question from Mohammed: What difference? What is the difference between a data scientist and leading a data science division? So basically, what is the difference in skills required to be a data scientist and to lead a data science division?
To lead a data science division, I think you need the skills of a data scientist plus a couple of other things. One, strategy, making sure that you're leading the department across the appropriate goals across all modeling projects, not on your individual modeling projects. And management, you need to be able to work with people to coach them to get the absolute best performance that they can achieve, not just what you can do best in the model you're working on right now.
Are the people skills required for a data scientist, such as communication, presentation? They're still people skills. Are they different, and how are they different to the management people skills required for a lead data scientist?
I don't think that they are different. I think the problem is people skip over them altogether. The quality of management in general in most organizations can be somewhat appalling, not just for people who manage data scientists, but for people who manage any type of group. And I think it's a real chink in the armor for all types of organizations. I think the difference would be that you may communicate to data scientists in their own language. You must be able to speak their language and be able to establish their trust and be able to work with them to get them to their highest performance. If you were dealing with an accounting team, you need to be able to speak the accounting language to be able to help them reach their highest performance. So it's not so much different skills, it's applying the right skills to the type of team you have, I think.
Gotcha. And I know you're passionate about leading data science teams. Why are you passionate about that?
Because I think so much can be done outside of just the algorithm. And
Mhm.
I think there has been such a push, especially in the past 10 years, on the type of algorithm you use. And algorithm isn't necessarily what's going to lead you to the best performance. I'm going to steal a story from Stephen Covey. And he said that pretend you had a bunch of folks and they're trying to lead a trail through the jungle. And they're like, okay, we're going to have Fred in the front of the group because he's really good at dealing with a machete. And we're going to have Michelle. She is the absolute expert at machete sharpening. And she's really good at that part, and et cetera, and so forth, and everything else. The leader is the one who climbs the ladder up and shouts down, wrong jungle. So you've got to be able to change. You need to be able to figure out if you're in the right jungle or not. And a lot of managers are not terribly good at that. And so you need to have that sort of holistic view in addition to the expertise of data scientists.
Okay, fantastic. What advice do you have for data scientists or advanced data scientists who want to become leaders or who want to become data science managers?
It's understanding a fact that all data scientists need to come to grips with, and that is that data science is not about data, it's about people. And let me explain what I mean by that. You're trying to solve people's problems. You're trying to help people. You're trying to communicate with people. Whether you're in accounting or data science or medicine or nuclear physics or social work or anything else, it's about people. And a lot of people come into our field, unfortunately, because they don't really like dealing with people. They like dealing with numbers more. It needs to
Mhm.
be a blend. At the end of the day, you're always trying to help people meet their needs. Data scientists use data and algorithms and techniques to be able to achieve that goal, but the goal isn't different. So, the more you understand people, communication, storytelling, visualization, the so called soft skills, that is going to be what greases the wheels to be able to get people to where they need to be and to solve their problems in the best possible way. You can't surrender on that and lead a data science team and be terribly effective.
Love it. So, not just data science leadership, but data science itself is about people. And if you one day want to become a data science leader, then start now. As a data scientist, start honing in on your people skills.
Yep,
What's
absolutely.
your what's the recommendation? How does somebody go about, like, there's not many online courses on people skills. There's a lot on technical skills. Where do you learn the people skills?
It depends on where you look. I'm actually going to push back on that one a little bit. We in the data science community like to read our data science blogs. And,
Mhm.
and if you focus there, that's where you're going to find most results. There are all kinds of resources. And I'll tell you, my particular favorite is the work that was done by Stephen Covey, and also my book recommendation. I'm going to sneak in here while you're not looking, which is The 7 Habits of Highly Effective People. And it talks a lot about people skills, talks a lot about problem solving that can be applied to data science or accounting or physics or sociology or anything else. Um, and focusing on those types of skills. Also, data visualization classes, not just to show how to visualize data, but you choose the visualization based on your audience and what that audience's needs are. Focus on that piece. What do I need to communicate? What do they need to be able to solve their problem? And how do I give them that? As opposed to, here's my way manky cool analysis that I did that's 700 pages long that no one's ever going to read. That's not the solution to the problem.
Mm, gotcha, absolutely. Let's move on to future questions. So, about the future. Snehal asks, what will be the next after advanced AI?
If we're not careful, we're going to run into another AI winter. And let me tell you what I mean by that. If you look at Gartner's hype cycle, where they talk about the stages of a technology, you tend to get overly hyped expectations, and then you end up falling off the cliff into what they call the trough of disillusionment. And we can bicker over whether those are good names or not. But if you set people's expectations too high and then you don't meet them, they don't tend to say, Scott Clendaniel's particular model didn't do very well. What they tend to say is, I knew that AI stuff was a bunch of hooey and we never should have invested in it. And I don't ever want to do a model again. I don't want anyone coming in here talking about statistics. I don't want to hear about machine learning. I don't want to hear it. It's all garbage because Scott Clendaniel's first model didn't do well. You need to really be aware of that. 85%, according to Gartner, of all models do not reach production. Think about that for a second. 85%. Our industry currently has a 15% success rate. I don't know of too many fields who can survive that. So, my big concern about AI is unless we get back to actually solving the organizational issues and fixing the problems, as opposed to, gee, look at my AUC, doesn't it look great? Um, the future of AI is going to go into a dark period for a while.
Okay. What about on the flip side? So Jacques asks, there's a fear that AI could replace humans in their jobs. What would you tell a concerned human being about that?
I would look at a lot of the research that's come out of RPA, robotic process automation. To the largest extent possible, in the conferences I've been to, is people's jobs don't get replaced. In other words, people don't get replaced. They get different jobs. meaning that if they're working in the accounting department, they stop working with copying stuff from Excel from spreadsheet A to spreadsheet B and get to work on, do we need the spreadsheet in the first place? That's not a bad thing. There was a lot of concern that AI was going to replace all kinds of people, and I haven't seen a lot of it happen yet. I don't think that radiology is the first career I would jump into right at the moment, because a lot of that is being automated. But you may end up with different types of jobs that a radiologist might apply, like how you apply the results from lots of different analysis from all kinds of different x-rays in terms of diagnosing a disease. I think some jobs always get replaced by technology. There aren't a lot of buggy whip manufacturing jobs left anymore. But I don't see AI replacing all kinds of people. The head of Stanford's AI lab had a great quote that said, "We're a lot closer to discovering a smart washing machine than we are of Terminators taking over the world." And I think that's true. I think we need to be careful of it, but I think people are perhaps overly concerned at this point in time that AI is going to replace everybody's job.
Gotcha. There was a report by the World Economic Forum in 2018 that predicted that I think by 2025 or 2022, not sure exactly the year, but AI will displace 75 million jobs worldwide, whereas it will create 133 million jobs. So that's a coefficient of
I think
1.7.
that's a much better example than the one I just gave. So yeah.
Well, I think both absolutely valid. What are your thoughts on AI replacing data scientists themselves, specifically AutoML and products like Data Robot?
I need to be careful here. I need to choose my words correctly in terms of
We
this.
can skip that
I
question.
think
That's okay.
that a lot of AI functions can be helped by automation. I think ensembling, I think picking the correct algorithm, I think hypertuning parameters, I think a lot of those will become automated. But there's a lot of room for creativity on the feature engineering side. There's a lot of room for creativity that's hard to replace. Even something as simple as ratios. Models are terrible at calculating ratios. They just are.
Mm.
And so, for example, if you think of a credit score, if you think of everything that I currently owe as one input, not a great predictor. If you think of how much total credit I have available, like if you add up the credit lines from all my credit cards and stuff, also not a very good predictor by itself. And if you used a classic algorithm to go and say, okay, let's throw them both out because they don't have high correlation to my result. The trick is the percent of utilization. So out of that big pile of credit, what percentage am I using is hugely predictive in terms of your credit score. It's those types of things on things as simple as ratios that I think are going to be hard to automate away. And I think that many functions may be assisted by automation, even in data science. I think if we focus on the right skills and the problem solving aspects and those type things, it is less likely to be automated away, at least in the short term.
Gotcha. Thank you. Very, very cool answer. Adley asks, does every business need to adopt AI?
No, is the short answer. Not every business does. Not every business does. And I think it's silly for us to pretend that every business in the world needs AI. I think every business could use to make better decisions than they do right now. And to the extent that AI helps with that, great. To the extent that AI doesn't help with that, no. Also, there are some businesses that don't have a lot of good data. And so if you don't have good data, you can't really build great models. So AI isn't going to be a particular help. I think that every business needs to make better decisions, and businesses that have access to good AI should take advantage of it. And those that don't worry about it.
What are your thoughts on Andrew Ng's comment that AI is the new electricity, and similar to how 100 years ago only 50% of the US was electrified, now everything uses electricity. AI will also, similarly but faster, be adopted by virtually all organizations. Otherwise, they'll be lose in terms of competitive pressure. What are your thoughts on that, with the thought in mind that not every business needs AI?
Well, let's follow that example through. You used to have organizations in the 1920s who had a CEO, but it wasn't a chief executive officer, it was a chief electricity officer
Mm,
whose sole responsibility was to how to figure out. I don't know a whole lot of organizations that are still hiring chief electricity officers. I think that better decision making, again, is the key more than AI itself. I think it's going to help more and more industries. I just don't think that you're going to have Vicky from iRobot making all the decisions for the planet. I think that is an overblown fear. I think it's going to impact more and more organizations. Um, but I think that we tend to go this sort of pendulum. No AI, it doesn't help anything, to AI solves everything. The answer tends to be somewhere in the middle, and just be aware of that.
gotcha. Okay, understood. Um, and one final question. This one will be from me. There's
Okay.
there's two main types of ways to structure your data science division. This is kind of like a data science management style question. So one is to integrate individual data scientists in across different functions like sales and then finance and operations and so on. And another one is to have a centralized data science team who service all those functions. What is your preferred style and why?
I'm going to steal this one from Harvard Business Review, and that's to use a hub and spoke model. You have a
Mm,
central core of folks who help the rest of the organization work on data science project. These are the folks who are going to be making sure that folks have the right tools that they need to help establish some processes, some standards, et cetera, and so forth. And that team is very small.
mm,
And that most data scientists sit in the individual group that they need to serve. And so your hub supports the people in the spokes in the different departments and help them achieve their goals. I think that is the best way to do it. You need, if you, it is so easy to have folks be in a data science group who are out of touch with the needs of their clients, that actually making them physically sit in that organizational structure helps solve a lot of those needs. So that's the way I would do it.
wow, fantastic. Thank you. Scott, it's been amazing. We've actually gone over time, but it was totally worth it. Loved these questions and your answers. Before I let you go, before we wrap up, wanted to ask you, what do you have like a recommendation or just like some piece of advice for specifically advanced data scientists out there who are listening to this podcast? Any like parting thoughts,
I do. And that
please?
is that uh, I'll tell it through another story. The first time I was ever invited to participate in an AI conference, I went running into my coworker's office, and her name was Beth. I said, Beth, it's fantastic. I've been invited to speak at an artificial intelligence conference. Isn't that great? And she folds her arms across her chest. She leans back in her chair. She raises one eyebrow and says, do you really feel qualified to speak at such a conference? And I was like, I did 10 seconds ago. There is a lot of folks in our industry who look like Beth.
Mhm.
That's a bad idea. We need to be inclusive. Get down off your high horse. It's a technology, it's an area of expertise. We need to be inclusive, not exclusive. Try and be nice to people. Try and help them achieve their goals. Common manners and being polite and listening to people are really important in any field. But if you're hoping for AI to have a big impact in your company, trying to prove how smart you are and how unsmart they are is a really bad idea. And there are way too many of us who do that. Be inclusive. Incorporate as many people as you can. Be as helpful as you can, and stop doing this sort of approach that I am some type of god of intellect because I know how to build a model. You can build a model in Excel, folks, and a lot of people could do that if only would someone take the time to show them how to do it. Be the person who's helping bring more people into the fold, not explaining to everybody else why they're wrong.
Mm. That's amazing advice, and you actually um, walk the walk and talk the talk, right? That's the saying. Like you live by that
Oh,
yourself
thank
because
you.
I look at your comments on LinkedIn, and you're always there supporting people, answering questions every time. Like even in this thread, people ask you a question. You'd not just say, answer the question and thank you, but you actually put a little image of a thank you, like a written thank you, every time a different one. I could just imagine you have like a whole library of these that you can use at given times. So yeah, it's really cool. Like why do you do it? Why do you help the community so much?
I think because I was treated so poorly by the experts in our field when I tried to break into the field, I
Mm.
like to tease with people that for the first half of my career, people told me I couldn't do this because I didn't have a PhD in statistics. And the second half of my career, everyone tells me I can't do it because I don't have a PhD in data science. And I was like, but some of my models seem to be working pretty well. I don't know.
Yeah,
And so I think that it's just, a way of bringing more people in and being helpful because people need encouragement. We've got enough people out there in the world telling everyone else that they're wrong. And I think, a little bit of kindness and support to other people goes a long way. And I think we're in better shape if we all just treated one another with a little more respect, a little more kindness, and a little less gruffness and a little less intellectual aloofness.
awesome. Fantastic. Well,
I don't
Scott,
want
thank
anybody
you.
else to have a 3-year-old on the phone saying, "Did you pack my toys yet?" with no prospects of finding a new job.
Yeah, yeah, I can imagine. Um, Thank you very much for sharing that. That's I think
Thank
it's
you.
a
I really
mm,
enjoyed this.
awesome. And me too. And tell us, how can people get in touch, follow you, connect with you?
The best way is to follow me on LinkedIn as T. Scott Clendaniel. I can't accept all the invitation requests because I'm almost at the 30,000 limit. They want to allow more people in. But please follow me. And if you have questions, send me a message. I can't answer everybody, but I do my best. I think I answered, gosh, over 2 dozen questions in the existing form, and I will continue to try and do that.
Fantastic. Thank you very much. Yeah, and you already gave your book recommendation. Could you just remind us? I think it was 7 Habits, right, of highly effective
Seven
people.
Habits of Highly Effective People by Stephen Covey,
Awesome.
who is no
That's
longer
too.
with us, but his legacy lives on. Great advice in there.
Gotcha. Um, Wonderful. On that note, once again, thank you so much, and we'll share all the links in the show notes. And please, guys, and everybody listening, connect with Scott. And uh, yeah, this has been a great opportunity to have you on the podcast. Thank you for coming.
Thank you. Take care.